Today we're going to be talking about similar triangles. So in 7-2 we talked about similar polygons, and today we're going to focus in specifically on triangles because triangles show up in a lot of other places. Remember how we talked last chapter about how you could even divide up other polygons into different numbers of triangles. Okay, so that's going to come in really handy, particularly when we have to do proofs. All right. Yes, proofs are coming back. So for example, we said before, if we wanted to know if these two triangles are similar or not, then we could go through and we could write a ratio of two sides, and we could test that for each of the two corresponding sides on these triangles. And so we would end up with AB over DE is 30 over 15. And when we reduce that, we would get 2 over 1. We could do BC over EF, and again, we would get 30 over 15, which is 2 over 1. And we could test out AC over DF, which would be 12 over 6, which again is going to be 2 over 1. And so since each of these reduces to the same number, they each have the same scale factor, then we would know that these two triangles are indeed similar polygons, similar triangles. Okay, but sometimes we don't have enough information to test out all three sides. Okay, so we want to know, are there any shortcuts? Everybody likes shortcuts. So our first shortcut today is AA similarity. Okay, so hopefully some of these abbreviations, the AA in particular, will seem familiar from when we talked about congruent triangles. Okay, so this time they're going to be a little bit different. Some of the acronyms will be the same as what we talked about before, but you have to pay attention to what they mean. Okay, remember that the acronyms are just there to help us remember them and to shorten it, but you still have to know how to apply them. So AA is going to stand for angle, angle. Okay, so angle, angle similarity. So let's look at a drawing. So we have two triangles here, ABC and DEF. And so if we know that angle A is congruent to angle D, and we know that angle B is congruent to angle E, then we want to know how is this enough information to know that the two triangles are similar. So we have to think, how does this help us know what all the angles are? Because first of all, we know that in order for these two triangles to be similar, all the angles have to be congruent. Okay, so we know that 2 out of the 3 angles on each triangle are congruent, and we know that all the angles on both triangles have to add up to 180, right? So that means if these two angles here add up to 130, the only option for this angle that's left over is to be 50 degrees, okay? And if A and B add up to 130, that means D and E are going to add up to 130. And so F would have to be 50 degrees, right? So then we would know all 3 angles on both of those are going to be congruent. And that's the first step in us being able to prove that these two triangles are similar. Okay? And guess what? That works no matter what measurements we give. So I just picked out the 2 angles adding up to 130. I made that up off the top of my head. But it doesn't matter what those 2 angles add up to. Whatever they add up to for triangle ABC, they're going to add up to for triangle DEF as well. And that means that your third angle on both of those is going to have to be the same, even if we don't know what it is. All right? And so that's really an important factor here. Another thing that we're actually going to know from this is that if those 2 angles, okay, and therefore the third angle, are congruent, then these 2 triangles are going to have to be similar. It's not possible for them to have leg measurements or side measurements that are not proportional if all 3 angles are congruent. It's just not possible. So as long as we can prove that 2 angles on one triangle are congruent to 2 angles on another triangle, then we know that those 2 triangles are similar. Now keep in mind, it has to be the 2 angles are congruent, okay, to two angles on the other triangle. So this would be two angles from the first triangle, triangle ABC, have to be congruent to two angles, on triangle DEF. Okay, and that's going to be true whether they mark those with the little arcs like I've done here, or if they actually gave you measurements. Okay, so be prepared to find some missing measurements in order to use this one. Our next similarity is side-side-side similarity. And so on here, if we don't know anything about the angles, but we can see each of the sides is proportional. Okay, so notice here, for ML to PO, we would have 5/10. For MN to PQ, we would have 5/10. And for LN over OQ, we would have 5/10. And guess what? Each of those is going to reduce to 1/2. Okay, which means they each have the same ratio, which means that all the sides are proportional. So as long as we can prove that just all the sides are proportional, then we're going to know that the two triangles are proportional. Now, that may happen on equilateral triangles like I have here, or it may be different measurements for each one as long as they reduce down to the same scale factor, or the same ratio once you've reduced it. Okay, then it still works. So side-side-side similarity. And that one probably sounds really familiar because we talked about that one with congruent triangles, but that meant each of the sides had to be congruent if we were trying to prove that the triangles are congruent. For similarity, we're just trying to prove that they are proportional. Right? Our next one also sounds really familiar. It is side-angle-side similarity. And it sounds familiar because we had to have two congruent sides with a congruent included angle to prove that the triangles were congruent. This time, we're going to have two proportional sides with an included angle. So our angle here is the right angle. That's the only one we know. And so that means that the two sides we're dealing with are this side here that is 3, and this side here that is 6, and this side here that is 4, and this side here that is 8. Okay, and we have to write our proportions. So we're going to do 3/6 and 4/8. And guess what? They don't look the same initially, but when we go and we reduce those, we end up with the same ratio for both of them. Okay, then we look at the angle. Remember, the angle has to be in the middle. Okay, it has to be included. Those two angles have to be congruent. So there's no proportional dealings with the angles. The angles have to be congruent, no matter what we're talking about here. And so with this, we would be able to prove, it's a shortcut, that these two triangles are similar, right? So how might this look if we were dealing with a problem in the book? Okay, because they may draw them out separately like that, or they might give you a picture that looks like this. Okay, so we're looking here, and we actually have two triangles. So let's be sure you can see both of them. So you have the smaller triangle on top, okay, and then we have the bigger triangle that is this whole shape here. Okay, so we're looking at those. And the first thing we're going to look for are any angles that we know something about. Okay, so I'm going to erase my drawings there just to make it a little easier to see. And you'll notice that this angle M up at the top is the same angle for both triangles. So we know that angle M is congruent to angle M, okay, because it is the exact same triangle, okay, or same angle, excuse me. Then we know that we only have one angle, so we're looking at our list, right? We have angle, angle, side, 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 and side, angle, side. Okay, so if we only have one angle that we know anything about, we obviously can't use angle, angle. We only know two of the three sides on both triangles, right? I don't know this side here on the small triangle or this side on the big triangle. So can't use side, side, side. So we're looking at side, angle, side, all right? And so that's the process we go through to see which of those shortcuts are we going to use. And so what that means is we need to write a ratio for each of those sides, okay? So we're going to start off, and it doesn't matter on this one when you're checking proportionality whether you do the small one over the large one or the large one over the small one, because all we're checking for is, are they proportional? Okay, so I'm going to use the small one first, and that would be 10 over the large side, and that's both of these. So I have to add 10 and 15 together, so that is 25. All right, then I'm going to do the same thing on the other side. So I have MP, which is 12, and I have MS, which is 12 plus 18, which is 30. And I'm going to reduce both of those. So we divide 10 by 5. It goes in there twice. Oops, wrong color. Goes in there twice. And 5 goes into 25 5 times. And then we're doing the same thing with 12 and 30. So 6 goes into 12 twice. 6 goes into 30 5 times. So these both reduce to the same fraction, right? They have the same ratio. And so that means that we know these two triangles are similar, right? So we'd write our similarity statement. So you would say triangle NMP is similar to triangle RMS by the side angle side theorem. Okay? So we'll look at some more examples in class tomorrow with some of the other ones. I really appreciate you watching. Thank you. Have a lovely evening. Goodbye.